So my name is John Bischof, and I'm a professor at the University of Minnesota. I am currently the director of an institute there. It's called the Institute for Engineering and Medicine. And we have about 270 members that cross between the College of Science and Engineering and the medical school. But we also have people contributing from College of Biological Sciences, College of Design, business school, and a variety of different units on campus. So it's a big institute. And our goal there is to turn science and engineering into medical practice to help people and to help society. Well, I have a really incredibly supportive family, and I have two grown daughters, and my wife, who's actually an intellectual, and she ran the Western European collection at the University of Minnesota for many years. She now works at Metro State as a tutor, and we like to spend a lot of time together on the weekends, hiking or biking or being outside. We enjoy spending time with friends and being together as a family. Yeah. So I grew up in California, in Berkeley, California, and so both my mom and my dad were graduate students at the University of California, Berkeley. So, being sort of immersed and around intellectuals and academics, it was sort of not a choice. It was what I had. But I had some fantastic mentors and godfathers and uncles and people, as well as my parents, that were really important heroes. One of my big heroes, in addition to my parents, is my godfather. His name's Dr. John Somerset. He was the first African-American PhD in English at Stanford. And then he was also the first African-American pilot in the Navy, if I remember correctly. And so he was a trailblazer, and he was an incredible intellect, and he was a constant part of my growing up because he was such good friends with my father. And so between Doc, that's my godfather, and my father, who was not in English, but he was in mathematics and physics and philosophy. And then my mom, who was, she ran the African American collection of the Doe Library at UC Berkeley. I had these incredible examples of people that found meaning in their jobs, who really wanted to change society and to be impactful and compassionate and helpful, if you will. I was very interested in science. I took foreign languages. My dad was German, and I spent a fair bit of time on also trying, doing sports and exploring, doing odd jobs here and there. So I worked actually in an automotive garage. I worked as a crane driver in a steel mill one summer. Actually, this was in Germany. And I just, I was able to try out a bunch of different things that convinced me that I really should stay in academics. So I also just continued to be curious about what the next course would teach me, or when would I know enough that I could actually do something useful. I think everybody wants to do or feel that they are being useful or doing something useful, or feeling fulfilled about what they're trying to do. And so those things drove me for sure. I didn't, again, always feel that on a daily basis, that I was like, wow, I'm making a great contribution or something. But I was always looking for something like that. So, I work generally in the areas of thermal bioengineering, I would say, and that can be applied in therapeutics. So, treating cancer or cardiovascular disease. It can be in diagnostics. The part where our big center is now is in cryopreservation or biopreservation. And that's this new NSF Engineering Research Center. It's called the Advanced technologies for the preservation of biological systems. One area is improving patient health through, cell therapies, having preservation technologies for cells that can be used in transplant, whether that's pancreatic islets or T cells or things like that. It also transplantable tissues and organs. Everybody's heard about organ transplants and the needs there. Drug discovery, which maybe seems a little bit odd, but you need to have tissues or organs or cells in order to test the drugs before you can actually use them. Well, we have the two protocols that have been developed now for fish, one in zebrafish that didn't exist before our collaborative group worked on it at Minnesota. We published in 2017 and then again in 2020 on a way to cryopreserve whole zebrafish embryos. So that's a huge breakthrough because no one's been able to do fish embryos before. And that's an important genetic model, biomedical model system, but it's also important for biodiversity. Well, I guess it was March of last year, when we all became aware that we were in the middle of a pandemic and things began to get shut down. It was actually my associate director, David Odie, who runs one of our programs in the Institute for Engineering and Medicine. He reached out to a variety of people around campus and just started a conversation about what is it that we can do. Together, David and I launched a program within the Institute for Engineering and Medicine where we quickly created these rapid grants, something around $10,000 a piece, to, just get it to investigators quickly who had creative solutions to some of the problems that we have, whether it's personal protective equipment or diagnostics or modeling of, what could be done with drugs to treat COVID in a clinical trial or whatever that might be. And what's kind of important to mention is that in many cases, in almost every case, it wasn't an individual faculty. It was a faculty member speaking for a group of faculty, which I'm really proud of. It really shows what the faculty of the University of Minnesota can do, but also what the Institute can do to help bring these teams together. So there were a bunch of others where people working, again, in anesthesia and working with patients that were being intubated and essentially they were passing away without having the opportunity to see their families. This resident came into the Department of Mechanical Engineering. She actually got in touch with Chris Hogan in the Department of Mechanical Engineering and said, I need a hood, or I need a box that I can put over my patients so they can be safe with their family if they have COVID, particularly in these final moments, but also, maybe just to have a visit. And so they designed a really, very creative solution where they used a HEPA filter and a fan, and they basically would suck the air from within. So the hood would go over the patient, but it was transparent so you could see. And they would suck the air out through this fan and the HEPA filter so that everyone in the room was safe if they're in there with a COVID patient. And this allowed for compassionate extubation, which is basically, allowing the patient to expire, but they're there with their family. And that was really, really touching and meaningful to so many. There are 6 open source licenses to these inventions that I'm talking about, so that anyone in the world can download these designs now, these engineering and scientific and group team solutions to COVID, and use them for the next pandemic or use them on COVID if COVID continues to be a problem in their area. So it's just a very dramatic, example of what can be done together. And if you think about it, $300,000 sounds like a lot of money, but it was 30 different projects. I'm just giving you the tip of the iceberg of what people have done. 30 different projects, all of them useful, all of them helpful, driven to help in the COVID pandemic. So I'm just incredibly proud of what the faculty did at the University of Minnesota, and that IEM was able to help with that. Well, I would say one thing is, like, I think that engineering is really, really powerful, and I'm really happy that I'm an engineer, and I wouldn't change that. But what I would say is that biology is amazing, and this is in some ways the century of biology, as many people have said, and I'm not taking credit for that. And especially when you're talking about being an engineer in medicine, which is what I do. I think the more biology that you have, the more impactful you can be, because the quicker you'll understand the problems and the better you'll be able to implement the solutions. So I think I might have told myself, take a little more biology